Good day and welcome to my YouTube channel. I am Arthur Francis Diban. Today we're going to be taking on the hydrocarbons, which is an integral part of organic chemistry. Hydrocarbon is the study of hydrogen and carbon, respectively. Then, in the hydrocarbon, we have classes like it is divided into aliphatic hydrocarbon, aromatic hydrocarbon, and so on. In the aliphatic, we deal with the straight chain and the branch chain. The benzene ring falls under the other one, and so on and so on. But the major objective today is to deal with the arcane side, which is the aliphatic. How do we write the molecular structures, the formulas, the ring, the reactions that are associated with it, and so on and so forth. As time goes on, we're going to proceed further to knowing how to name organic compounds, which is very important. In short, it is very, very important. So, in the hydrocarbon, like I said, the arcane generally, we're going to look at their general molecular formula. Then we look at the classes. Then before we can now proceed. So let's take, for example, in the aliphatic, which I say arcane, is the pivot which we are concentrating on. We have the arcane, we have the alkyne. But let's take alkanes, for example, which we have a general molecular formula of CnH2n plus 2. With this formula, we can name all sorts of alkanes. We have methane, ethane, propane, butane to decane, which is 10. But how will you know if you're dealing with 8? First, you must know the serial order of the naming, of the nomenclature. That 8 is what? Octane. 7 is what? Heptane, and so on. Now, how many carbon atoms are there, or hydrogen atoms are there in octane, or in heptane, or in hexane? Now, this formula, the CnH2n plus 2, will help you to know exactly how many carbon and hydrogen atoms are there therein. Let's take, for example, pentane, which is 5. Alright, this is the formula here. I can easily say C5 for the N is the number which we are proceeding, which pentane is 5. So this becomes C5 H2 times 5 plus 2. Now I have my C5 H2 times 5 is 10 plus 2, 12. So this becomes H12. So this becomes our what? Molecular formula for what? Pentane. Through the aid of the formula here, the general molecular formula for all alkanes, we can now proceed to deal with either propane, butane, and so on. So if this is the molecular formula, the structural formula therein, remember alkanes have this catenation. The link in the bonding between carbon and carbon is called catenation. So if I want to name it, I have 1, 2, 3, 4, 5. Don't forget that carbon is tetravalent, which means that it must have 4 substituents surrounding it. It mustn't have more than 4. If you have this as your carbon and you have this and this, let's put it this way, you should know that this is wrong because the number of bonds associated with the carbon are more than 4. Carbon is tetravalent, which means this becomes the original or the true formula, which is C, H, H, and H, which makes it 1, 2, 3, 4. It has to be 4. So, to that end, if this is my pentane, so remember I have to put the 5 hydrogen atoms because from the formula here I say C5, 1, 2, 3, 4, 5, H12. So if I put my hydrogen surrounding it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this is correct because the number of hydrogen atoms are equivalent with the carbon atom. So let's look. If we say carbon is tetravalent, which means it must have 4 bonds surrounding it. This carbon atom has 1, 2, 3, 4. This one has 1, 2, 3, 4. This 1, 2, 3, 4, and so on and so forth. There should never be a case where you have 5 bonds enclosing 1 carbon atom. Mostly when we get to the alkene family, you see things similar, and students make a whole lot of such mistakes. You will see when we get there. So the first one we took as an example is the pentane. Let's take another example. Propane, for example. Propane means 3. So this is the formula. Means anywhere I see N, I put 3. So I will come over here and say C3H2 times 3 plus 2. C3H6 plus 2, 8. So now the structural formula, this is the molecular formula. The structural formula becomes 1, 2, 3. 1, 2, and 8. So if I put my 8 hydrogen, 1, 2, 3, 4, 5, 6, 7, and 8. And so on and so forth. So with this, now we can easily write out the structural formula for any member of our cane. Let's take the cane, for example, which is 10. So this is CnH2n plus 2. So this becomes C10 H2 times 10 plus 2. C10 H2 times 10, 20 plus 2, 22. So the structural formula would therefore become this. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have my 10 carbon atoms. My hydrogen now become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. So one of the most important things you must know and take into cognizance is the number of the first 10, let's put it that way, of the alkane family, which is methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. If you know that your first 10 falls within that rate and their numbers, then you can now use this formula perfectly. But if you do not know that propane is 3, then how will you know where to put what to put in the place of N? Because you do not know that it is 3, then you don't know the exact value to put in there, and that will become a problem. So it is imperative that first thing first, we must know the first 10 members of the alkane family, have it in our head. That when I say hexane, you know it's 6, octane is 8, nonane is 9, methane is 1, and so on and so forth. So methane is 1, so this becomes C1 H2 times 1 plus 2. C, that is 1C now. H2 times 1 is 2 plus 2 is 4. So CH4 becomes our methane, and this is base. So ethane, the same thing, which is you put it and know how many hydrogen atoms. If you do not know the number of hydrogen atoms, you will not know how to draw your structural formula. So if I may ask you that, draw the structure of propane. First thing first, I know the general molecular formula CnH2n plus 2. Second, I know that propane is the third member of the alkane family, third. So if I put it into the formula, I'll have C3H, how many? 8. So by that, you can easily draw your structures and put your hydrogen atoms. We are going to get into numbering, but until then, numbering or naming of organic compounds. When we get there, you see the intrinsic factors associated with it, how interesting it is when we understand the rules. We must follow the rules in naming of what? Organic compounds. But then let's proceed further. Now we're going to look at the classes of the hydrocarbons. Now, the classes of carbon atoms, we have the primary, the secondary, the tertiary, and the quaternary. These classes are very paramount. Now, I'll give you a practical example. So I say primary, secondary, tertiary, and quaternary. So, if this is my carbon atom, okay, let me draw a compound. From it, I will illustrate the primary, secondary, tertiary therein, and we'll take some other examples. By that, we'll complete our definition. If this is a compound, okay, Now, let me put my hydrogen. I use this structure to define the various classes. We'll talk about primary, secondary, and tertiary. Now, here, this carbon atom is attached to one other carbon atom and 3 hydrogen. Let's listen attentively, it's very important. Now, I want to name my primary, secondary, tertiary, and quaternary. So when a carbon atom is attached to only one carbon atom and 3 hydrogen, it is primary. Primary, 1. It is attached to one carbon atom. Let's take that. If you say primary, that's 1, 2. Secondary, 3. Tertiary, 4. Quaternary, alright? So we'll use the carbon situation to define what we're looking for. We'll say primary carbon. Remember, we're talking of carbon, classes of carbon. Now, primary carbon is a carbon that is associated with one other carbon, that is linked with one other carbon, and 3 hydrogen. If you want to put the 3 hydrogen, but the most important thing is it is attached to one carbon atom. So I can put 1 here and call that primary. Now, we move down to, okay, let's take this is 4. I call this 4, this is quaternary. A quaternary carbon is that carbon that is attached to 4 other carbon atoms and no hydrogen. This carbon is attached to one carbon, one carbon, one carbon, one carbon. So this, I put 4 in there. It is quaternary. I will want to take this a little further so I will get them all complete. Another hydrogen here. Now, tertiary carbon is that carbon atom that is attached to 3 carbons and 1 hydrogen. But now, I don't think I have anyone that is here. But let's look at, okay, yeah, this is tertiary, 3. It is attached to 3 carbon atoms, 2, 3, and 1 hydrogen. That is tertiary carbon. Now, secondary carbon is attached to 2 carbon atoms, 2 carbon atoms, and 2 hydrogen. So, by definition of the classes of carbon here, I said earlier on, when we say the primary, secondary, tertiary, and quaternary, the primary carbon is attached to 1 carbon atom only. If you like, put it and 3 hydrogen. Fine. Secondary is attached to 2 carbon atoms, tertiary 3 carbon atoms, quaternary 4 carbon atoms. So I will write a structure where we are going to use it as a question to see how we answer it to get what we are looking for. But by virtue of what we have here on the board, I've been able to explain to us what a primary carbon is. A primary carbon atom is attached to only 1 carbon and 3 hydrogen. Secondary, 2 carbon and 2 hydrogen. Tertiary, 3 carbon, 1 hydrogen. Quaternary, 4 carbon and no hydrogen. Why do we have to add the hydrogen therein? Because each carbon is tetravalent. So if it is attached to 1 carbon, what about the other 3 bonds that are associated to carbon? So the other 3 bonds are hydrogen bonds. So that is that. So by definition, a primary carbon is attached to 1 carbon atom and 3 hydrogen. Secondary, 2 carbon and 2 hydrogen. Tertiary, 3 carbon and 1 hydrogen. Quaternary, 4 carbon and no hydrogen. For example, this carbon is quaternary. It's attached to 1 carbon, 1, 1, 1, 4. And there's no hydrogen. It's not linked to any hydrogen. Tertiary, it's linked to 1 carbon, 2 and 3. 1 hydrogen. Secondary is linked to 1 carbon, 2 carbon, 2 hydrogen. Primary carbon is linked to 1 carbon and 3 hydrogen. Primary, 1, 3 hydrogen. Primary, primary, primary. So, by virtue of that, we understand what we are dealing with. The primary, secondary, tertiary, and quaternary word carbon as the classes of what? Carbon. Let's take a question. Okay. Let's take a question. Now, in the question here, we have to identify primary, secondary, tertiary, and quaternary word carbons before we move further into other reactions. Now, it is important we note something. When we're dealing with naming or this carbon stuff in hydrocarbon, where we put our carbons, we put our hydrogen. But it is also imperative we know at least at the A level, you should know that whenever you see carbon, you should have it in mind that there are hydrogen associated with it. Unless we have to go back to our secondary level, which is the high school level, where we have to show how the hydrogens are all associated. If I have this, I don't need to be told that this is propane. It is the same thing when I put my hydrogen here. Hydrogen. Now, at the A level, it is not wrong to write it as this. Or as this. 1, 2, 3. This is the same thing as propane. But now we have various ways. We have the condensed formula method, we have the zigzag formula method, and so on. So, we will not talk about, let's leave all this. We can look at this and the condensed and this elementary method. Now, wherever you see your 3 hydrogen, have it in mind that there are, you see your 3 carbon atoms, have it in mind that there are hydrogens attached to it because carbon is tetravalent. If we have to be writing the hydrogen, yes, we can do that. It may take us time. Like, for example, if I want to put all the hydrogens therein, it may take us time. But maybe for the sake of emphasis, let me just put the hydrogen and see what we make out of it. But before I put the hydrogen atom, from here, you'll be able to also know and identify the primary, secondary, and tertiary what? Carbon. We say a primary carbon is bonded to one other carbon atom. So this guy is bonded to just one. So I can give him 1. This guy is bonded to 4. 1, 2, 3, 4. I give this guy 4. This one to 1 carbon. This one to 1 carbon, which is this. This one to 2 carbon. 1, 2. This one to 4. 1, 2, 3, 4. This one to 3. 1, 2, 3. Tertiary. This one to 1. So this one to 1. You have 1. This one to 3. 1, 2, 3. Tertiary. This one to 4. 1, 2, 3, 4. Quaternary. This one to 1, which is just this. This one to 1, which is just this. This one is 2. Secondary. This is primary. This is 2. Secondary. 1, 1. This is primary. This one is bonded to 1, 1. So I give him 2. This is 1, 1, 2. This is just 1, 1. So by virtue of this, you can easily look and know the carbon that is primary, that is secondary, that is tertiary, that is quaternary, based on the bond linking. Is it bonded to 2 carbon, secondary, or 3, tertiary, or 4, quaternary, and so on and so forth. So by virtue of this is what we can get on alkanes. The general molecular formula which we can use to elucidate the structure of that molecular of that compound you want, or let me call it propane, butane, hexane, or whatever it is. If it is hexane, you know you're dealing with 6. You can easily put in the general molecular formula CnH2n plus 2, and you'll be able to get your carbon atom and the number of hydrogen atoms, and you arrange them. And also important, you must know that the aliphatic doesn't necessarily mean that it must be straight chain. It can also be branch chain. If I have this, all this is the same thing as 1, 2, 3, 4, 5, 6, hexane. It mustn't be 1, 2, 3, 4, 5, 6. It mustn't be straight chain. So without the hydrogen, you should know, count the parent chain, how many of them? There are 6. You name it. 6 is what? Hexane. When we get to where we deal with substituents and naming of various compounds, then you will also understand. So let us proceed further. Let me see. Okay, the rules for IUPAC nomenclature of alkanes. Before we get down into the rules, there are a whole lot of rules. I will take my time to deal with the rules. But then, let us look at some reactions of alkanes. Some of the basic reactions which alkanes undergo, but others doesn't. And when we get to alkenes, we also see the reactions they undergo, and alkanes doesn't. So, aside isomerism, which all of them will undergo isomerism, we have the 2 basic, which is substitutional reaction and combustion reaction. Combustion is where the alkane react with what? Oxygen. While substitution reaction majorly happens with the halogens. Could be bromine, chlorine, fluorine. So we'll do one of them, example, and see how the others will play out. All right, let's take one here. Methane reacting with oxygen in combustion reaction. Let's see. The first example of a member of the alkane is methane plus oxygen. What do we get? We're going to balance it. So when you do that, you have to know what and what you get. Is it water, CO2, and in what rate? So if I have my CO2 plus water here, we have to now check. How many carbon atoms do we have? We have one. We have oxygen here 2. We have oxygen now 3. So if I put 2 here, I have oxygen 4, and I put 2 here, I have oxygen 4. So by virtue of this, I said my equation is balanced because carbon is 1, 1. Oxygen is now 4. 2 plus 2 is 4. Hydrogen is 4, which is 2 times 2 here, 4. So by virtue of that, we say the equation of reaction is what? Balance. That is what? Combustion reaction of what? Alkanes. So let's look at substitution reaction. In substitution reaction, we say it reacts with what? Halogens. Let me check the basic rules. But then, we can still use our methane reacting with chlorine, yes, and see what happens. Chlorine gas. Okay? So let's go down to substitution. I have my CH4 plus Cl2 in the presence of light or heat. Let's put it that way. Now, in substitution reaction, it's just like in football. When you play ball, they say you substitute. One of these guys will be moved to join this, and one of these will be moved. Now, what is left? If one hydrogen is out, let's take this guy. One hydrogen is out, one chlorine is out. What is left here is one chlorine and CH3. So I have my CH3, what is left? Alright? Then one chlorine that is left here, I bring it down. This is chloromethane. And the other guy that left will now become HCl. So we are substituting. We are going to carry out the process gradually till we get to the end and see what we get. So now, if this is what is left, we continue to substitute until we get to the end of this. So now, if I bring out this, my CH3Cl, which is my chloromethane, plus another Cl2, having the same state in the presence of ultraviolet light. Now, one hydrogen will move again. When this one hydrogen moves, I will be left with CH2. CH2. Now that hydrogen, let me put the hydrogen. This is where the hydrogen is. Now, this chlorine is here already, but this other bond, remember one will go to join the hydrogen and one will come down here. This other chlorine that comes here, 2, which I was having, okay, this is 1. One other chlorine becomes 2. And the chlorine comes here. So we have dichloromethane. We continue to replace. If I go further, another hydrogen will move out. Another chlorine will join. I will have CHCl3 on and on. So now I have my CH2Cl2 plus Cl2. If this goes, now this is what I have. One hydrogen will go, I will be left with CH. I have 2 chlorine here. One chlorine will join it to become Cl3. Now that is fixed. That hydrogen that moves over to join the leftover chlorine will give us our HCl. I still have hydrogen. I'm substituting for what? The hydrogen continuously till I exhaust them all. Now the next one, I'll bring this trichloromethane, CH Cl3 plus Cl2, and this will give us This hydrogen will now leave. I will be left with no more hydrogen. So I have C, no H. I was having Cl3. One chlorine will come now to give me Cl4. That hydrogen that leaves will come down here to give me HCl. So this is tetrachloromethane because I'm having 4 chlorine in this methane compound. So this is a complete substitution reaction which happens with the alkane family. When we get to the alkane family, realize there we deal with something else, which although all of them will undergo combustion, but the other one will become addition reaction, no longer substitution reaction, which is the basic difference between the reaction of the alkanes and the alkenes. Alkane undergo substitution, while the alkenes undergo addition. So you will see when we get there. So this is the preliminary state which we have to take this. If you have this in your head, you can easily draft out what happens to the rest. What if the methane decides to react with bromine? Let us see how we're going to do that. Alright? Of substitution reaction with bromine. So I have my CH4 plus bromine molecule here. Now, in substitution, these 2 bromine, one of it will come and take 1 hydrogen. And 1 hydrogen will meet the other bromine. That's all, to give us hydrogen bromide. So let's assume 1 hydrogen has left. We now have CH3. Now 1 bromine here will come over here to join this, okay, to give us Br. What is left? The hydrogen that left, this is the hydrogen. The bromine, remember there are 2. The other one will give us Br. So this is our first step. Then the second step, I will bring this bromomethane to undergo the reaction again. I have my CH3Br plus Br2. This will still give me. Another hydrogen will move. We are doing substitution. Another hydrogen will move. I'll be left with CH2. 1 Br. So when that Br comes, the Br becomes 2. So I have CH2 Br2. Now the hydrogen that left, this is it, and the bromine left is this. Okay, now I move further. That bromomethane will come over again. I have CH2 Br2 plus Br2. 1 hydrogen will leave again. I will be left with CH Br2 plus the bromine that comes here give you Br3. Are we together? Now we have hydrogen bromide again. Hydrogen bromide. Now we bring our base down here. I have CH Br3 plus my bromine again, molecule. Now we are substituting the last stage, which is this hydrogen is going to be moved. Now I have C, no more hydrogen. I was having Br3. When 1 comes down, it becomes Br4. And the hydrogen here that moves, this is my hydrogen and the leftover bromine. This is tetrabromomethane. So by virtue of this, we have also done the substitution reaction for bromine. And this process can continue. We can still do the same thing with iodine. So that one will be, you can solve it and comment on the comment section what you get therein. Then we can now proceed. So let me just give you what you're going to do at your own private time. Comment in the send your answer at the comment section. I will say it. So we have the CH4 plus iodine molecule. The first step, I have my CH3, 1 hydrogen will go, and 1 iodine plus hydrogen iodide. So if you proceed with this, the next step, 1 hydrogen will leave, and we have 2 iodine. The third step, another hydrogen will leave, 3 iodine, the last iodine will leave, hydrogen will leave, and we'll have 4 iodine, which is so on and so forth. So do it for your own personal aggrandizement. Let's put it that way. Welcome back. Like I said, we are going to be dealing with the rules involved in naming organic compounds. So let me take this out. Alright, there are a whole lot of rules, but we're going to follow them one by one. One very important thing when it comes to naming of organic compounds, first, is to be able to identify your parent chain. If you know how to identify your parent chain and the substituents therein, then you know what you're dealing with. This is what I mean by that. If I have this, let's call this. Okay, this is the compound given. The first thing we have to do is to identify the parent chain. The parent chain is often the longest chain. So how do we do that? You begin to check. From here I have 1, 2, 3, 4, 5, 6, 7. That is, for me, it seems so as if it is the longest. If I take this, 1, 2, 3, 4, 5. If I take this, 1, 2, 3, 4, 5. Either this, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So either way, this way or this way, I am good. So that is the first thing you must know to identify what your parent chain. So let's look at the rules first together so that we'll see what we get. It says select the longest unbranched chain of carbons as the parent chain. So that's what I just did. The longest unbranched chain of carbon as my parent chain, and name it as that of the corresponding alkane. So if it is 7, I want to name it as the corresponding alkane. It becomes what? Heptane. Because all the ANE for alkane must go with the group members: methane, ethane, propane, butane. So if this is 7, I have first of all check my longest chain, call it 1, 2, 3, 4, 5, 6, 7, and I name it correspondingly as what? Heptane. Now there are other guys here. This one now are called the substituents, which happen not to be in the parent. They are all linked to the parent chain, but they are not a party. They do not play part in the parent chain naming that make up the heptane. So they are all called what? Substituents. So this substituent, we have various kinds of substituents, which I will list them out, I think so. We have the methoxy, we have the ethoxy, we have the ethyl, propyl, butyl, and so on and so forth. We have the hydroxy OH, we have the chloro, Ca, bromo, iodo, and so on and so forth. So let's move on. That was the first thing they have given to us. Let's take example when they talk about the longest chain. So we have 1, 2, 3, 4, 5. Apart from this, let's take another example. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. See. So they say I should identify my what? Parent chain. It's either I call it this 1, 2, 3, 4, 5 as my pentane. So this becomes my substituent. If I call it 1, 2, 3, 4, 5 as my pentane, this becomes my substituent. But the most important thing is I have identified what? The longest parent, the longest chain, which is the parent chain. 2. Assigning numbers serially to the carbons in the parent chain, starting from the end nearer to the first substituent, the side chain. So let's see a practical example. We can still use the one I have given here. Let's look at the same first. After identifying our parent chain, that's rule number 1. The rule number 2 is we should assign numbers to it. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Starting from the end, nearer to the first substituent. From the first substituent, this is my substituent here. Which side is nearer to this or this? If I want to count from here, this is 1, 2. If I want to count this side, it's 1, 2, 3, 4. So this substituent here is nearer to this side. So my numbering becomes 1, 2, 3, 4, 5. Remember, they say first Identify your parent chain, which is often the longest chain. 2. Assign numbers to that parent chain starting from the end nearer to the first point where your substituent is. So this is my substituent, and that point nearer is this side. So I start from here 1, 2, 3, 4, 5. So that student who would have this 5, 1, 2, 3, 4, 5, and you have your C here, and name it as 1, 2, 3, 4, 5. You're wrong. This is obviously completely different from this, so you cannot get the same answer. Yeah, will be wrong. So let's take another rule. So we have done that first one, and we have numbered them. Now the third one says, when two unbranched carbon chains have the same number of carbons, the chain with more substituent is the parent chain. As the example here, let's take this example. Okay. Let's take this example. Let me write it out. Now let's listen to the rule and know what we are doing. When two unbranched carbon chains have the same number of carbons, the chain with more substituent is the parent chain. So that example will tell us, when you count 5, for example, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All of them are 6, 6, 6. The question now becomes, which one do I take? They say the chain with the highest number of substituent, the one that has the highest number of substituent, become what? Our parent chain. So having counted these 6, let me now check the number of substituent. 1, 2, 3, 4, 5, 6. The substituent here is 1 and 2. So the first one gave me 2 what? Substituent. So I can clean this now. I have 2 substituent in the first one. If this is my parent chain, presumably, I'm counting. Now, if I come from 1, 2, 3, 4, 5. Okay, this is not even complete. 1, 2, 3, 4, 5, 6. Okay, this one is also 6. Now, the substituent is 1, 2, and 3. So, if I come from here downward, I have also 6 like the other one, and the number of substituent increases. This one is 3. So officially they say when you come from both sides and you have the same 6 in both, or 7 or whatever it is, you should now consider the parent chain with the highest number of what? Substituent. And this one definitely becomes my parent chain. So this becomes my 1, my 2, my 3, my 4, my 5, my 6. This becomes my parent chain. So we have not started naming them officially. I want us to finish the rules so that you understand when I make certain pronouncement because of what? Naming them. Because now if I go on, I want to name this. I say, this is 1, 2. This is a methyl. Am I right? And this one is an ethyl. 1, 2, 3, 4, 5, 6. There's another methyl here. Now, some of us may not understand that the ethyl will be pronounced first. Alphabetically, E comes before N. There is a rule that will tell us that. So, 1, 2, 3. We have 3 ethyl. Alright? Now, 2, 5 dimethyl. I have 2 methyls in 2 and in 5. So, it becomes 2, 5 dimethyl. Now, what is the parent chain? 6 hexane. So, that becomes the name of this organic compound. So, this is 3 ethyl, 2, 5 dimethyl hexane. Remember, when you are writing, let's call it 3 ethyl, 2, 5 dimethyl hexane. You must join them. You don't space hexane. Hexane. That's one common mistake we make. And I think you see that as we proceed further in the naming, in the rules you see. Now this is 3 ethyl, 2, 5 dimethyl hexane. When you space the methyl from the hexane, you are wrong. So that's how the rule goes. So let's continue. We are going to name many of them, tons of them. But before we get into the process of naming, we will see how we understand this whole thing. So that's the third rule. The fourth rule, when naming a substituent becomes a prefix joined to the parent name, and with its number or locant separated from its name by a hyphen. Now, these are the locant. Okay? These are the locant. These numbers which you have, 6, 5, 4, 3, whatever, are the locant. So you must take the locant into consideration. They are separated from the main name with a hyphen, and within two locants, a comma is used to separate them. So these rules we must have to follow. And also, if I do not see it, I just have to add to it. Let's take another rule. When the same type of substituent occurs more than once on a parent chain, let's take, for example, we have two methyl, one methyl and one methyl. When more than one occurs, what do we say? On a parent chain, their locants are separated by a comma, which is this, a comma between them. Okay, by a comma, an appropriate prefix, di or tri. How many of them? There are two, we call it di. If there are three, we call it tri. Tetra, etc., added to the name of the substituent. Let's take another example. So first, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if this is what it is, but take note, your total locant must be lower when you are considering your parent chain. Listen, and listen attentively. Your total what? Locant. If I have this as 1, 2, 3, 4, 5. Another person have here 1, 2, 3, 4, 5. Let's consider where the substituents are. The substituents from this side are in 3 and 4. 3 plus 4 is 7. The substituents from this side are in 2 and 3. 2 plus 3 is 5. The lowest possible number or counting of locant is your parent chain. So it means the numbering must go from this way and not from that way. Are we together? The number must come from this way because here it gave us the lowest possible number of counting. But from this side we have 7, this side we have 5. So we abolish this other side. That side will be wrong. So many of us may make that mistake of starting from any position without minding where you should. At the end of the day, what you have will be what? Wrong. So here, like I was illustrating, if this is what it is, I have 1, 2, 3. In carbon 2, I have a methyl. Don't mind that I'm not putting my CH3 here. My CH3 here. We know that. I've explained that earlier on before I started. For those of you who are just coming in, you may not understand that. So now, if this is my methyl, this is my methyl, I have two methyl, I must have to show whether they are di or tri or tetra, as the case may be. So here become 1, 2. In carbon 2, I have a methyl. In carbon 3, I have a methyl. Am I right? So this become 2, 3. How many methyl? 2. 2 is called dimethyl. 1, 2, 3, 4, 5 as my parent chain, pentane. So that is how we move. You must take note of that. We're going to encounter a whole lot of questions which we are going to deal with. So when we get there, we'll cross. Let's continue numbering. Now, when the same substituent type is present more than once on the same carbon in the parent chain, its locant is repeated as many times as required, which is 2, 2, and so on and so forth. Let's take a practical example to that. We have this one, the locant is repeated as often as possible. So let's take this one. 1, 2, 3, 4. I have CH3 here, CH3 here. This is H3, remind me, H2, H3. This is in the condensed form. So now, if I want to count from here, first of all, I want to identify my parent chain, alright? I start from here, 1, 2, 3, 4. Now I have 4, but they say you should take the lowest from the lowest possible side of the substituent. 1, 2. So this one is 2. So this is where I should definitely start. So I have 1, 2, 3, 4. So this becomes my parent chain from this order. Now in carbon 2, I have 2 methyl attached to it. Alright? Now they say you should repeat the number of locan as possible, as many times as possible, to reflect the number of times those substituents are attached to it. So now in carbon 2, I have 2 methyl. So I say 1, 2. So I have 2, because in carbon 2, I have 2. Alright? 2 dimethyl. Dimethyl. How many? There are 2 methyl here. Dimethyl. 1, 2, 3, 4. 4 is butane. So why am I having 2 is because in carbon 2 I have 2 methyls. So this is 2 dimethyl butane. So we are going to name a whole lot. Let's proceed further. Now we say again, when there are 2 or more different types of substituents, we have more than what? 2 substituents on the parent chain. They are arranged in alphabetical order. However, the presence of di, tri, tetra, etc. does not affect the alphabetical arrangement. Hence, let me give us a practical example that can illustrate that. Let's take this. Now, remember, I have explained earlier on in our first class that all of these, carbon is tetravalent, but you should also know that your carbon, your hydrogen are attached to them. So let us see. We say when there are more than one substituent that have different from one another, we name them in alphabetical order. If this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, obviously I can now take from here because 1, 2, 3 is closer. Somebody tell this one to stop the moment. 1, 2, 3. So this side is closer. So I have it here as 1, 2, 3, 4, 5. So now if this is what I have, this is a methyl and this is an ethyl. So how do I name it? I have to name it alphabetically. 1, 2, N, ethyl, E. So obviously this comes before this, am I right? So this becomes 3 ethyl, 2 methyl, 1, 2, 3, 4, 5, pentane. Okay, methyl pentane. Remember, do not space it. It's very important. If you space it, it becomes strong. Let's move further if we have more rules. 8. When any of the following heteroatoms or functional group are substituents. Now we will have to tell you what are heteroatoms. They are named as prefixes to the parent names as indicated. Here, let me give you, we have the bromo, which is BRO, chloro, CL, fluoro, iodo, I. We have the nitro, NO2, the nitro group, is a functional group. We have the methoxy, OCH3. We have the ethoxy, OC2H5, and so on and so forth. Now let us take a practical example that has to do with all of the heteroatoms therein, and we'll name them accordingly. So first, let us identify our parent chain. Then we name them accordingly. Now, if I want to start from here, this is bromine, this is chlorine, this is methoxy. So from here, 1, 2, 3, 4, 5 is my parent chain, or 1, 2, 3, 4, 5. So if I want to start from here, 1, 2, 3 bromo, 4 chloro. So 3 plus 4 officially is 7. But if I start from here, 1, 2, 3 bromo, 2 chloro, that's 5. It means I should start from here. This will give me the lowest possible count from these two. and this is methoxy. Alright, now let us see what comes first. We say alphabetically, am I right? So, alphabetically we have B, A, B before C. So B will come first, bromo, then we have chloro, and we have methoxy. So let's begin. 1, 2, 3 bromo, 3 bromo, 2 dichloro, because we have 2 chlorine and they are all in carbon 2, so that becomes 2 dichloro, 2 dichloro, 3 methoxy, 3 methoxy, 1 2 3 4 5 pentane. So that becomes the numbering. So you don't forget that alphabetical order is very important. Some of us may decide to start from the chloro first, forgetting that B comes before C. And when once that happens, you have made that mistake, and that will be very wrong. So let's take more questions. Okay, we get it. Now, from our parent chain, 1 2 3 4 is closer than 1 2 3 here. So this is methyl, this is ethyl, alright? So if I call this 1 2 3 4, this is my methyl. So I have E for 1 2 3 4. 4 and 3 will give me what? 7. Am I right? Yeah, 1 2 3 4. 4 and 5 will give me 8. So the counting must start from here because the possible number of the locant comes from this direction. Am I right? So that's number 1. We have identified that. So now this becomes 1 2 3 4 5 6 7. Now if you look here, I have a methyl group. I have an ethyl group. Alright? So ethyl will come first, which is this. But it is just not a normal ethyl. It has a substituent in it. So I will come over here. I want to start with 4. In carbon 4, I have an ethyl, which is 1 2. This is the ethyl. So in 2, I have a chlorine. So this is 2-chloroethyl as a substituent in a substituent. So this guy is inside. So what do? I start from here, since that ethyl must come first. So this is my 4 for that. Open bracket. I must have to put this inside. So here I have 2 ethyl, 2, sorry, that's chlorine. 2 chloroethyl. I'm done with this, am I right? Close my bracket. 2 chloroethyl in carbon 4. Remember, I'm supposed to say 4 ethyl. Now in 4, I have this. So that is why I have 4 outside. Put this hyphen to tell you what is inside 4. So this is 4, open bracket, 2 chloroethyl. 1 2 3. 3 methyl. 1 2 to 7. Heptane. 3 methyl. Heptane. So that becomes the name. When you have a substituent inside a substituent, you must first of all show here that this number 4 contains another substituent inside of it. You must show it before you proceed with the naming. Otherwise that will be wrong. Let us move further and name more. This is another example that has something inside of it. Alright. We have to first identify our parent chain. Now, if I start from here, 1 2 3 4 5 6 7. Okay? Okay, but this is a methyl. But this side is ethyl. Alphabetically, this one should be considered before this. But this one is an ethyl. So it is in between. Both sides give you 4, both sides give you 4. Now, why am I giving consideration to this other side? Only because this is Cl and this is N. Chlorine comes before methyl. Am I right? So by so doing, I start from here. So if this is my 1, 2, 3, 4, 5, 6, and 7. Now, this is a substituent, mind you. But in this substituent, it contains other stuff inside. Alright? So here I can call it 1, 2 if I like. Now let me start with my naming. I have Cl and this is ethyl, E. So A, B, C, D, E. So I will start from here, am I right? So 1, 2, 2 chloro, 2 chloro, 4 supposed to be 4 ethyl, but there are other stuff. So I have it 4 open bracket. In the ethyl, I have 1,1 dimethyl inside of this ethyl. So this becomes 1,1 dimethyl ethyl. That's what I will put inside the bracket before I move. So here I now have 1,1 dimethyl ethyl, close the bracket, 5 methyl heptane. Let me break it down. 1, 2. In 2, I have a chloro. So 2 chloro, 4, 1, 1. In carbon 1, this is my ethyl. 1, 2. Give me ethyl. 1, 2. But in carbon 1, I have 2 methyl. So I have 1, 1. In carbon 1, I have this 2 here. So it becomes 1, 1 dimethyl ethyl 5 methyl heptane. That is the name. Now let's take like 3 more examples in the naming process before we move further. I know we're going to deal with isomerism and so on, but it may not be today, but let's see what we can do. Alright, what is this one? No noise, please. Now, without wasting much time, we have to consider the parent chain first. Am I right? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Either way, if we call this 4, we call this 64. If I take this as 4, this becomes my substituent. If I take this as 4, this becomes my substituent. So let's just deal with this. This one, 4 as our parent chain. So the parent chain is 4. Which member of the alkane family have 4? Butane. So first, our parent chain is 4, butane. Now, the substituent, they say we should consider the side closest to the end from the substituent. So if this is my substituent, if I take from here 1, 2, this is 2. It's closer than 1, 2, 3. Am I right? From here is 2, from here is 3. So I should come from here then. 1, 2, 3, 4. So according to that rule, this is the numbering. And each number is called a locant. So the lowest possible locant should be taken very seriously. 1, 2. Give me this. This side is 3. So 2 is considered. Now, in carbon 2, I have a substituent. What's the name of CH3? Methyl. Good. So the substituent name is what? Methyl. So now I would want to name it. We say 2-methyl butane. In carbon 2, I have a methyl attached to it out of the 4 carbon atoms. So this becomes 2-methyl butane. So by so doing, we have just name this one as 2-methyl butane. You don't have to memorize it. You just have to understand it. And when you understand, you flow. Let's take another one. So now we have to consider our longest chain, the parent chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All of them will give us 5. Then, if I take either this 5, this becomes my substituent. If I take it straightly, this is my substituent. If I come from this way, these two are my substituent. Let us deal with the straight chain, which is what? 5 in all. Now, let's consider where do we start from? Is this supposed to be the lower side or from here? Where do we call our 1? So let's check our locant. This is 2, 3, 4. Okay? 1, 2, 3, 4. But here in 2, we have 2 2s. Alright? Let's call that 2 plus 2, 4. For example, 4, 5, 6. So 4 plus 1, 6. But if you come from here, this is 2, 3. And you call this side 2 plus 2, 4. What do we get? 4, 5, 6. So either way is giving us the same thing, but let's take 3 as our shortest possible side. 1, 2, 3, 4, and 5. Now, in naming it, if you look here very well, you realize the substituent. What is the name of this substituent? This is the substituent. What is the name of this substituent? Methyl. 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 They are all what? Methyl. So now, if I start from here, this is 2. In carbon 2, I have 2 methyl. Am I right? So this becomes 2, 2, 4, because there is another methyl here. 2, 2, I've captured these 2 methyl. Another methyl is here in 4. Trimethyl means there are 3. 2, 2, 4, trimethyl pentane. Do we understand that?
Yes.
2, 2 what? 4 trimethyl pentane. By so doing, we have that all named out. So this is 2, 2, 4 trimethyl pentane. Let's take more, like 2 more, 3 or more than that. Depends on how the spirit leads. Okay. Quickly, we'll take 2 of these, then we'll go to interpret the condensed structures, which you may see anytime. If we now know how to interpret our condensed structure, then technically you should be able to answer any question that will come your way. So now let's go. Let's take this one. Okay. If this is what it is, let's see. B comes before C, am I right? So this is 1, we have B, 2, 3. So this is 1, in 2 here we have alphabetically this comes first. Then these 2 are even closer from here, which is 1, 2. Here will give us 1, 2, 3. So this side will give us the lowest possible word count. So if we want to start, B comes before C, L. 1 group, okay, let me name it. Number 1, 2, 3, 4. 1 bromo, 3 chloro. Remember alphabetically, you cannot call methyl before chloro. You call the alphabetically, this one comes before this, am I right? So 1 bromo, 3 chloro, 2 dimethyl butane. So by that we are good. So now we have 1 bromo, 3 chloro, 2 dimethyl butane. All right, let's take another one. Now, remember, first thing first, you identify the longest or the parent chain, which is the longest chain. So, if we look from here, 1, 2, 3, 4, 5. Good. 1, 2, 3, 4, 5, 6. Okay, obviously this is the longest. Alright. So if that is the longest, let us check our locants and see which side we are going to start. If I start from here, let's call this 2 plus 3 plus 4. 4. Then we move further. We start from here, 1, 2, 3 plus 4 plus 5. So this is 7, 8, 9. This is about 9, 10, 11, 12. So we must start from this side, not from this side. So if you start from here, obviously you will be out, because the lowest possible locant comes from this direction, not from this direction. You must do your calculation before you begin. So if that is the case, I will now number this 1, 2, 3, 4, 5, 6 as my longest chain. Now, F is fluoro. NO2, sorry, this is not NO3. NO2 is nitro. It is a heteroatom. And this is methyl, and this is methyl. So alphabetically, F comes before what? N, Abi? No, N, then N. So F comes first. This is second, Abi? And this is third. Is it also? M, N. So now, if this is the first guy I have to deal with alphabetically, so let me name this guy. 1, 2. We say 2 fluoro methyl comes in. 2, 4 dimethyl, because there's a methyl here in 4. Look at it. And there's a methyl here in 2. Am I right? Am I right?
Yes.
Do we understand?
Yes.
In carbon 2, there is a methyl. There is another methyl here in carbon 4. Look at how well we direct ourselves. 4, 5. So this is a substituent now. Because this is in the parent chain. This is the parent chain. So this becomes a substituent. So now in 2 fluoro, 2, 4 dimethyl, methyl. Where is that guy? 3 nitro hexane. 6 nitro hexane. So that is how it goes. Very importantly, you must take note of that. So we should take a little of the condensed structures which can be given to you, and they will ask you to name it. So when it is given to you, you bring it out to make it larger, or you expand it, you simplify it before you proceed. In organic compounds, there are different forms. We can put them in the zigzag manner, in the condensed manner, and so on. So let's take one of them here. They say we should write the structural formula showing all bonds and the IUPAC names of the following. Now we have number 1. Now this is a condensed structure. They want you to simplify it, that you'll be able to name it and do whatever they ask you to do. Now what does this mean? This means that this carbon has 4 methyl group attached to it. Are we together? This carbon has 4 methyl group attached to it. Therefore, I have my carbon here. The 4 methyl group. 1 CH3, another one CH3, another one CH3, and another CH3. If you look very well, you realize that here I've not been writing it as CH3. This and this are not the same. Although it can be ignored that you are writing it in this form, it can be ignored, but it is preferable you write it this way, because the bond between carbon is interacting with another carbon, not with a hydrogen. So it's carbon-carbon bond. The process is called catenation, where carbon bond within themselves. So this is now what I have. The question here says that you should write the structural formula, which is this now, all right? Showing all bonds, all of the bonds are visible, and the IUPAC name of this compound. Now, what is the IUPAC name? If I count from here, 1, 2, 3, 1, 2, 3, 1, 2, 3. Either way, they are all 3. So I just call it 1, 2, 3. So if this is true, now in carbon 2, I have 2 methyl attached to it. So this will become 2,2-dimethyl propane. 3 is what? Propane. Dimethyl propane. Alright, so we have 2,2-dimethyl propane. So our interest majorly is to be able to write out the structural formula and name it. Presuming that it wasn't given to us, it's like I'm giving you a structure to name. That is what we're doing. So let us take another structure and name it the way it should. So this can be given to you any moment, any time. But you have to use your senses to deal with it. Now, the first thing here we have is CH3. This is my C. H3. This is what I have. Now, here we have CH2. You know each carbon atom in between is having 2 hydrogen with it. So, but they say that this CH2, there are 3 of them. So I will now have CH2. This is 1. H2, this is 2. H2, this is 3. I move forward. This carbon atom contains 1 hydrogen and 2 methyl groups, CH3 and CH3. This is what it is. So now we have the structure and we are asked to name. Obviously, 1, 2, 3, 4, 5, 6. Our parent name is what? Hexane. How many substituents do we have? Just 1. And it is in either 1, 2 or 1, 2, 3, 4, 5. 2 and 5, which one do we consider? 2, because it is closest to the beginning. So this is 2-methyl hexane. So can I write that? 2-methyl hexane. Let's take another. Now, this is 3-methyl group that should be attached to this carbon. So I have this carbon here, this one, the 3-methyl group CH3, CH3, CH3. That's settled. With this guy is over. Now this one here, I have my C. I have hydrogen and a methoxy group attached to it. OCH3. I extend. This carbon here, I have 3-methyl group. CH3, CH3, CH3. Now let us name this. From either side, they are the same. So let's just move. 1, 2, 3, 4, 5. Let's call it that. 1, 2, 3, 4, 5. Now, methyl and methoxy. Which one comes first? Methoxy. So 3-methoxy. This one. Sorry, yeah, I'm right. 3. 3-methoxy before methyl alphabetically. Now 2,2,4,4 tetramethyl pentane. Are we together? In carbon 2 we have 2-methyl. In carbon 4 we have 2-methyl. So we repeat the locant as many times as they appear. So now this becomes 3-methoxy 2,2,4,4 tetra methyl pentane. So that is that. 3-methoxy 2244 tetramethyl pentane. So that is the name of this compound. So you must take note and name it what? Religiously. I know there will be a section in your exam that has to do with name the following organic compounds. If you remember your basics here, I don't see how you're going to fail it anywhere in the world. So take note of that. As you move harder or higher, let's put it that way, in organic chemistry, you're bound to see things that will make your eye want to turn, but you know how to deal with it. Okay. Now, they say we should write the structural formula of the following. 2,3-dimethyl-butane. I think that is straight up. 2,3-dimethyl-butane. You just, your butane is 4. 1, 2, 3, 4. They say 2,3-dimethyl-butane. That's that. Those are walkover questions. Now, the IUPAC nomenclature of the compound above. Okay, this is very important. Most of us will make mistake in this. Let's take this as our last one. And I strongly believe even if I should allow you to name it, 99.9% of you will not get it. But let's see. They say, what do they say we should do with that guy? We should give the IUPAC nomenclature of the compound. It's a jam question. They have options here, various options. 5-ethyl-octane, 5-propylheptane, 3-propylheptane, 4-ethyl-octane. We'll see which one is correct. Now, let us break it down. This is my CH3. I have 2 CH in 3 places. 1, 2, 3. This one is done. And here I have C, which contains hydrogen, and C3. 1, 2, 3. H7. 1, 2, 3, 4, 5, 6, 7. Move further. C2. This is my C2. H5. 1, 2, 3, 4, and 5. Now, if you see it this way, this is a substituent, if you want to capture it that, or base is a substituent. But now, according to the rules, they say we should name the longest parent, the longest chain, the longest possible chain as the parent chain. So if I want to name the longest, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So this becomes my longest. A lot of the students may likely go this way because it is horizontal. And by that, you will not get it right. So if this is true, 1, 2, 3, 4, 5, 6, 7, 8. That noise is terrible. So here becomes 4-ethyl-octane as the name. So 4-ethyl, this is CH2, this is your substituent. All of these, this is the parent chain this way. This is attached to this as your substituent, which is C2H5. So that is your substituent. So the question, the answer to that question in JAM, they say 5-ethyl-octane wrong, 5-propylheptane wrong, 3-propylheptane wrong, 4-ethyl-octane. That is the answer.